What movie are we watching again?
Something like the 1910s.
Why does the TV look like that?
Bro, right?
Have you ever asked the same question as them before?
Where did you come from?
I'm the guardian angel from the Sue Lab, and I'm going to answer all your questions by showing you what we do.
No way. Then explain this.
The miniaturization of electronics stems from all the research that has been done on silicon as a semiconductor, which has made it possible for industries to make the small yet multifunctional phone you have in your pocket right now.
What, this? How is this supposed to fit in our phones?
Well, industries use lasers to cut silicon ingots down.
Wow, let's just keep cutting it down then.
No, there's a reason we can't do that. Imagine if we keep cutting a piece of cake. Eventually, we're going to reach a limit to what we can cut because it's just so small. Also, if we cut the cake, how do you know each slice has the same amount of filling and sponge? In that same sense, it's hard to precisely cut down silicon from a top-down method and standardize its electronic and physical properties, which is why our lab is trying to do a bottom-up synthesis method. Instead of cutting something down to something tiny, we start with the smallest possible material, atoms, and stitch them together into nanoscale electronics.
That sounds hard. How would you do that?
Well, come with me.
How'd you get here?
Welcome to the Sue Lab. This is where all the magic happens. In 2005, Martian proposed several steps to get to SiAd, the smallest unit of bulk silicon. Now, our lab has worked to optimize the process to figure out how this little molecule works. Oh, that's the SiAd finishing up right now.
So this is what it looks like?
It's like a whole bunch of white powder. Why do you guys think this is gonna do anything?
This isn't the first adamantane structure research. In fact, carbon adamantane, the smallest unit of diamonds, is something already seriously explored and used in various applications such as medicine, catalysis, and materials.
So then what does this have to do with this?
I was just about to get into that. We can't do much with just one unit of silicon, so our lab is working on functionalizing different positions of SiAd in order to elucidate ways we can branch off from this material. Even more so, this is why our lab wants to explore what we can do with SiAd, because it could probably do much or maybe even more functions with its different electronic and physical properties.
I get what you're saying, but how are you even going to measure these properties?
Here, let me show you how we measure a property like conductance. This is the STM-BJ, or Scanning Tunneling Microscopy Break Junction. This basically measures the conductance of SiAd. Let me show you an animation where the individual molecules are wired between electrodes and tunneling electrons are transmitted through the molecule.
Oh, I see. So in the bigger picture, your research could lead to new applications for new silicon materials?
Yeah, think about it like this. The first integrated circuit is what got us to space. Now we have technology that's 1,000 times more powerful thanks to that discovery. Think about what we can do now, or where we can be years from now. Currently, industries are spending trillions of dollars to cut bulk silicon down to smaller sizes. As researchers, we have the capabilities to go deeper and propose a bottom-up approach that is more efficient than the techniques used today.
Wow, I didn't know that all this research was going on about silicon, or how you're approaching this physical limit.
Oh no, hurry, before the grass students come back. Anyways, if you want to know more about the Sue Lab, visit the lab today. I gotta go home because I gotta cook more SiAd. Bye!